Hello, assalamu alaikum. Today I will present a comparative analysis between two important machine learning algorithms, decision tree and random forest. The focus of this presentation is understanding why random forest usually performs better. So for this experiment, I use the Heart Disease Dataset. I will perform both random forest and decision tree on the same dataset so that we can measure the proper trade-off between these two popular algorithms in machine learning. So the main question behind this work is if decision tree already perform well, then why do we need random forest, right? To answer this, I trained both models on the same dataset and compared their accuracy, overfitting behavior, generalization capability, and overall performance. The goal is not only to compare matrices, but also to understand the reasoning behind the performance and performance difference. So let's look at the dataset overview. For this experiment, I have used the heart disease dataset. The dataset contains medical information such as age, cholesterol, chest pain type, blood pressure, and heart rate. On the left side, we can see the target class distribution. The dataset is relatively balanced: 499 patients without disease and 526 with disease. On the right side, the correlation heat map, we can observe that the feature like chest pain type, maximum heart rate, and old peak have stronger relationships with the target variable. So another important observation is that the data relationships are non-linear, which makes tree-based models very suitable. The slide shows the feature distribution and outlier analysis. Most patients are between 50 and 65 years old, and the cholesterol distribution is slightly skewed and contains several outliers. The box plot actually, the box plots also confirm the presence of outliers in features like cholesterol and blood pressure. One advantage of decision tree random forest is that they naturally handle outliers, nonlinear data without requiring normalization. So now let's look at the decision tree model first. Decision tree works by recursively splitting the data into smaller regions based on feature conditions. From the visualization, we can see that the tree become quite deep and complex, but the model achieved 100% training accuracy, but 98.5% testing accuracy. Although the accuracy is very high, this also indicates a risk of overfitting. The tree memorized many training patterns very closely, which can reduce robustness on unseen data. So let's look at the random forest model. Decision tree is become very complex and high chance of, okay. And now for the random forest is ensemble learning method that combines many decision trees together. So each tree is trained on random subsets of data and random subsets of features. The final production is made using majority voting. The random forest achieve 100% training accuracy and also 100% training accuracy. So the feature importance graph shows that okay. Now let's look at the model generation gap, the train versus test comparison. This slide compares training and testing performance. The important concept here is the generalization gap. The formula is training accuracy minus testing accuracy. For the decision tree, the gap is almost 0.015, and for random forest, the gap is almost zero. I mean completely zero. The performance, this compares the both models across multiple evaluation metrics. We can see that random forest consistently achieved better performance in accuracy, precision, recall F1 score, and AWC score. So the ROC curve also shows that random forest achieved an AUC of 1 indicating excellent class separation capability. Overall, random forests provide more reliable and stable predictions. So let's look at the why random forest performs better. Actually, the problem of a decision tree is this is a single model and sensitive to noises, high variance, and overfitting. But a random forest solves this problem using bootstrap sampling, feature randomness, and majority voting. Instead of relying on one tree, it combines predictions from many trees. So the mathematical formula is this is the core ensemble equation used by the random forest. So if we say when to use which model, so this is very clear actually. Both decision trees are preferred when interpretability is important, simple rule-based decisions are needed, and or the dataset is small. Random forest is preferable when accuracy matters more, the dataset is complex, and overfitting needs to be reduced. So in practical application, random forest is generally more reliable for real-world prediction tasks. In conclusion, we actually have the decision tree are simple and powerful, but they can easily overfit. Random forest improves performance by combining multiple trees through ensemble learning. So our experimental result shows that random forest achieved better generalization and lower variance and higher overall performance. So that's all from my end. Thank you so much.